maybe I will. Um, all right, word problems. So when sketching the graph of a quadratic equation within a context, this is on page 32. Yeah. So context means there's text around it, right? So it's a word problem. You must label the axes with words and units. This is for grade 12 as well. Time. What is it? Time in minutes, seconds, hours, what is it, right? So you're gonna have to have like a word actually attached to that axis and what units am I in. Start just like before by finding the vertex and the intercepts. I already, yeah. Are you gonna do it second period as well?
Yes.
Oh, okay.
Yeah.
Could have saved me.
The you or me.
Yeah, I know that. Yeah,
Thank you.
yeah. Could have saved me 5,000 steps. This will give you a good idea of what the scale you use when asked to graph. Okay, like that's why I'm asking you to find the vertex and the intercepts, because that tells you a good box to have around your graph. Most of the time, variables need to be positive, so the majority of the graphs will be limited to quadrant 1. Can I just say this though? The majority, not all. Majority will be in quadrant 1. But there are instances, for example, I have one where a pelican or whatever dives underwater and then comes back up. So there will be a little bit of negative height depth to it, but most of the time we're in quadrant 1. So keep that in mind. Don't think it's all the time, right? And so we have, for example, this is an equation here, and you should already realize this is height in terms of time, right? And then you have your quadratic formula. Some of you will recognize this from physics. If you haven't done this already, if you're in grade 11 physics, I believe you will start looking at, what do you call that? Displacement or projectile motion, right? You'll do that in grade 11 physics. Where height, in terms of time, represents the height in feet, and t represents the time in seconds. So I'm going to tell you this. Whatever is on the left side, this is the y-axis. I'm never going to trick you. I'm never going to trick you. Even in grade 12, you're guaranteed that the first variable is your y-axis. And this variable here is your x-axis. Okay, so the equation should help you. Where should I put what? So h stands for height, right? We're told. So you go over here, and somewhere along the y-axis, you say height and feet. And then you go to the x-axis, and that's time in seconds. So we go time in seconds like that. Don't just go time. You gotta add seconds to it as well. Okay, and then obviously you should recognize that this is the y-intercept, and this is your x-intercept. This one right here. No surprise, it's nothing new. But now it's going to be something else for us. In this particular scenario, if this is height and this is time, this is what we call the initial height. The height at time 0. Okay, so initial height is found by you finding the y-intercept. Okay, so when time is 0, right, height is y-intercept. So it will be something 0 number. Okay, guaranteed 0 number is that. And the x-intercept within this context is what? Let's write this down over here. Time the object remains airborne. Okay, that's what this will tell you, right? So it'll be x, the x value will be the time that it was spent in the air, and 0 is, right, obviously you're hitting the ground, so your height is 0. Hits the ground, let's put that down, hits the ground. So in this particular scenario, right, something is launched up in the air, reaches the maximum height, and then comes down and hits the ground. The object will not always hit the ground. Sometimes there's a trampoline question where somebody's launched, or somebody's jumping off their balcony onto the trampoline. Don't do it, right? But right, like you would land somewhere here. But this is just a scenario to get you ready. So this is what we call the vertex. No surprises, right? But what does that give? So we're gonna put an arrow there. Gives maximum height after x seconds, right? Because the vertex has an x and a y component to it. This being the time, this being the height, right? So if it had been 3, 5, you would know that after 3 seconds, it reaches a maximum height of 5 feet, right? If this had been 0, 3, you know your initial height is 3, and so forth, okay? All right, let's keep going. Maybe one more thing. I'm going to try to add this right here. When you see something like this and it says h represents the height, t represents the time in seconds, I want you to think of, right, every single x value represents time and every single y value represents height, right? So your x and your y normally get replaced now with time and height. So every coordinate has a pair, right? It's paired up in that way. That's very important, okay? And so let's talk a little bit about domain and range now, and this is where things change. No longer, you know what, infinities, like far and few in between, right? You don't have infinity symbols anymore in this case. So for domain is the x values, right? And range would be your y values, like the restriction on your y values. You're basically saying, hey, where does the graph appear along the x-axis and where does the graph appear along the y-axis? I will say this, no infinity symbol, right? Exclamation mark. This is rare. So keep that in mind. So if you ask set notation, you would say, okay, in this case, this is very important. My x variable is actually t. There's no x, so you got to go with whatever the equation uses for your x value. If it uses s, then use s. If it uses d, then use d. Whatever they use, it is crucial. Okay, t is there. So we would say that the variable t goes from 0, like if this is, let's put a little 0 here. This is time 0. And along the x-axis, you keep going, you keep going, you keep going until you get to your x-intercept, right? So you would say the x-intercept in this case, right? Interval notation, this is easier. You just go from 0 till the x-intercept. Square brackets on both sides. And you're going to practice this in a bit. What does it say here? In general. It doesn't say always. It says in general, you will probably encounter this in general. Y values. So here it's a little trickier. So in this case, we have h as our y variable. And so you will go lowest y, between the lowest y and the y of the vertex. lowest y, all the way up until the y of the vertex. And it translates to this: lowest y, comma, y of vertex. Okay. So keep that in mind. This is just a guide to help you out. Let's practice that. Are you feeling it? So much fun. Okay, I'm gonna use two different highlighters for this one. So if you have two different colors, this is where it's gonna come in very, very handy. So I have a bunch of scenarios. These are all word problems because look at your axes, right? Length versus the area. They both have units. So let's go ahead. I'm basically gonna say, okay, let's look at our x-axis and travel along the x-axis. As long as we see a graph, we're gonna travel along it. And it stops right there. So that will be my domain. That is the domain. So let's go ahead and use our domain here. Domain, you just have to go D and like that. Let's do the easier one first. For me, the interval is the easiest. So this is considered 0. So we go all the way from 0, keep going, keep going, keep going. What's the x value over here? Look at the coordinate. It goes all the way to 450, right? So that means that my domain goes from 0 all the way to 450 feet. And now the one we don't like as much is the set notation. The reason why I'm still doing it, because you still have to be able to read it and understand it. You may not have to state it, but you still have to be able to read it and understand it if I'm giving you the domain in this format. So you have to use squiggly brackets. I'm going to use L for length. Okay, you can use lowercase, uppercase, it's up to you. But there's a number on either side, right? So it's L is going to be bigger than, right? Bigger than 0, but less than or equal to 450. And there's your domain in set notation. So how about I do this? Interval set. Okay, so you know what's the difference. Next year you're going to do a unit called set theory. And we're gonna do a lot of this kind of writing as well. For our range, let's look. I have green for that one. Okay, so you go, where does my graph appear along the y-axis? And I'm going to go from here. I see graph, I see graph, I see graph, I still see graph until I get to the vertex. So I'm just gonna do this to let me know. I see graph along the green here. If I travel along the y-axis, that's where my graph appears. And the lowest y value is 0. And what's the highest y value? This is where students mix it up. 50,000. Yeah, this is the y value we're after, right? So 50,000. So then my range goes from 0 all the way to 50,000. Yep, they're gonna be big numbers because sometimes we look at profit, right? Making $250,000 for the business, right? Based on sales. So it happens, but it shouldn't scare you at all. We just use a different scale. We would go up by 10,000. That's what I would do. And then for the range here, if you want to do it in this way, same thing. I'm going to use A for area. Because most likely if it's a word problem, you're not using X and Y. All the way to 50,000. Okay. I want to give you at least one chance to do this. I want you to use both notations. For, let's try just this one right here. And if you have time, you do this one as well. I will probably ask you to try all of them for homework, just to practice our domain and range a little bit. So go ahead. You know what? Actually, if you just want to do interval for now, that's fine. Just use a pencil, okay? So try both of these using interval notation only for now. What would be my domain? What would be my range? We put your devices away for a bit and hone in, right? See if you got it right. So I'm going to do the highlighter thing. Sorry, it might bother some of you, but for domain in this particular, I see the curve going from here to here along the x-axis. And it's implied that this is 0, and I go all the way to 17 along the x-axis. So my domain would be 0 to 17. No variables in the interval notation. So that's why I like it as well, because then you don't make a mistake in that regard. For range, I'm going to use my green one. You got to watch out, right? You see the curve at 0 all the way, keep going, and some students stop there. Because hey, the curve is touching right there. But you still, imagine you're looking to the side, you still see the curve all the way to here, okay? You see it there. So as long as you see a curve, you got to keep going. So it goes from 0, right? 0 all the way to 18. Right? Sorry, did I say? Yeah, 18. So you go from 0 to 18, not 15, right? So the vertex is always most likely going to be part of your range. Okay? All right, so here we go, domain. This will be 0. What are we going to use? I'm going to use T, 0 to 17. And then range, it goes from 0. I'm going to use H for height all the way to 18 like that. So you're saying, hey, between these two values. You know what? Why not? Why not do this? Right? Domain gets a pink highlight there, and the range gets that. Right? Here we go. And I'm curious how you did with it. How you did here. I'm very curious. So domain and range. So domain. I see curve right at 0. I keep going. I see curve. At first it's at the bottom, now it's at the top, but I still see curve. Boom. Stops there. 10. So my domain goes from 0 to 10. Right? 0 to 10. My range, let's see how that goes. I don't know about that. You always want to go lowest, highest with domain and range. You always go lowest, highest. So you tend to travel from the lowest point up along the y and from the lowest point up along the x. So I see curve, and it stops right there. Okay, stops right there. So I'm actually going from -20 for the y all the way to +3. Okay? +3. So if you look at the y values, you go from -20 all the way to +3. I hope you got this one. If you did, go like this. Good job. Okay. Good job. And so domain, that's so silly, Mr. Dixon. I'm never going to do that. T, and this goes all the way to 10. Okay. Range from -20 all the way to 3. Let's tell a story on this one. How can we make a story out of this one, Mr. Dirksen? I don't know. Maybe there's a submarine, right, or something, and launches a rocket, right, underwater, goes up, and then it hits a target, right? Like, so try to imagine a story behind it, right? All right. How are we doing? Is this boring? If it's boring because you got it, I'm happy. right? I'm happy. If it's boring because you're like, I have no idea what you're talking about, then it's a different story, right? Okay, domain here. Let's do it a little faster. 0 to 4.5. Would you agree? I hope you agree, because curve starts here. Curve stops right there. Okay, so that's 4.5 here. This is 4.5, and this is 0. So you're going from 0 to 4.5. Range. You're going from, do I start at 0? Nope, because there's no curve in this stretch here. So I actually have to start here, right, lining up with that lowest point, and then keep traveling. I see curve, stops right there. So basically figuring out the y values that are acceptable for this scenario. So you go from 13, this is 13 here, obviously not drawn to scale, guys. I hope you understand that. So from 13 to 32, you must have lowest first, greatest second. Do not mix them up, right? I'm repeating myself a lot, so I kind of want to drill that. It's 0, t to 4.5. Why are you using t, Mr. Dirksen? Because time, right, on the x-axis. Why are you using h? Because, is it almost time? Yeah, you're already thinking of the weekend, right? So domain and range. Let's go to the last one here. Did you finish this one? Okay, if you did, this was going to be your homework. So I'm just gonna, do you want me to give you the answer? I'll give you the answer, because probably you're never on your phone, so you would never go on your phone to check the answer key, right? Right? Yeah. So 0, you go from 0 to 2.35. Let's go, right? And range from 0.18 all the way to, what's the highest point? 3.45, right? That's the highest y value in this picture. And here, domain is 0 to 100. And range is negative 37.85 all the way to the highest point, which is 37. Bingo. Okay. All right. I'll tell you this. Monday, I will post the video. I'll do it at lunch probably. Or I'm going to use an old one. I'm not sure. But we're doing word problems. This one right here on 36. I'm going to take my time going over it. Make sure you write down the notes. Okay.